Welcome to the Network Engineering Video Blog. I'm your host, Michael Crane. Well, today we're going to talk about RIP. And, some might say it's a dead protocol. Others may not. Let's take a look. So, some fun facts about RIP. It is old. It is probably the oldest routing protocol that's non-proprietary, meaning wasn't developed by a business like Xerox or somebody like that, or IBM or what have you, that I know of. So, and the first RFC for it was written in, as you can see there, June of 1988. So, what is that, 30 years ago or about? That's pretty old. The second rev of RIP came out 10 years later in 98. All right, and then the cryptographic authentication came out in 2007. So, and then there's this RIP NG, which stands for Next Generation. I actually never used it, so we're not going to talk about it too much. From what I understand, it's just supposed to support IPv6. But if you're going to be messing with IPv6, I wouldn't use RIP anyway. So we're going to look at RIP version 2 today. So with that history that you can see right here, so is RIP dead? I mean, it was last updated about 10 years ago, or 11 years ago, right? So, you know, that's fairly recent, I guess, right? So let's look at some pros and cons with RIP. RIP is super easy to set up. And you'll see it's only a handful of commands to make it work. And it works pretty good, actually, as long as you don't have too many routers in the network, and we'll talk about that. It's definitely faster to provision, like if you're setting up a new router or adding a new network to a router. It's definitely faster to set RIP up to push those network routes out than it is to add static routing. Okay, and it works really well in small networks. So those are the pros. Some of the cons. It has a counting to it's a convergence problem, which means if something goes south and it's trying to, let's say a router falls out, and you got a pretty big network, and it's trying to figure out all the routes. It tends to do the hop count, you know, and it sits there and it'll just keep incrementing it by one, which is the metric it uses to calculate the routes, or calculate the cost of the route, or the metric. And it'll sit there and do it until it hits 16 and then stop. And 16 in RIP is infinity. And I know it sounds small, but that's the way it works. And you can get on the RFC. They have if you read the original RFC, which one is that? Yeah, that RFC 1058. They've got a really good write-up on this counting to infinity problem. It's quite interesting to read. So then we have a scalability problem. The RFC actually says not over 15 hops. I would suggest not over 5. If you're gonna have 5 or more nodes in a network, I would probably use another routing protocol like OSPF. In fact, if it were me, I would use OSPF. But yeah, so you know, if you got 3 or 4 nodes and you know, you just want to set something up really quick, it'll work perfectly for that. RIP doesn't support IPv6, like we mentioned previously, but RIP NG is supposed to. And like I said, I wouldn't even use RIP if I was using IPv6. And since it's not really being developed actively, I think they've stopped development on it. So some of the new routing protocols it might not interact with in the future. So you might keep that in mind. before setting it up. If you're planning on growing this network, and well, if you're planning on growing any network, I'd probably not use RIP. But if you're just, you know, need it for something quick and dirty, it's great. So, okay, so when should you use RIP? Let's see. In networks less than 5 nodes, like I mentioned, you're not planning on growing the network, right? Not using a mesh network topology. And this right here, this bottom example right here, this is a mesh. And you have to excuse my new green screen. I'm still trying to get used to it. And so if you got a real simple network like this up here, where you're just going from node to node to node, or you know, some little combination of that, it'll be just fine. But if you're going to go through the trouble of meshing your network like this, where you have complete redundancy, I would use OSPF. I wouldn't. If you're going to go through that much trouble to do this to your network, I would use a better routing protocol. Okay, and the not using mesh network. Yeah. Oh, and the network is an autonomous system, and autonomous just means it's owned by the same organization or person, right? So our test network that we have in the lab here is an autonomous system, and they also have exterior gateway protocols, would be something like BGP. Okay, so all right, let's here's some need-to-know details for RIP. RIP v1 and v2 use hop count for their routing metric, like we were discussing earlier, the counting to infinity thing. A metric of 0 means the route is directly on the node or the router. A metric of 16 is infinity, which means it's unreachable. And that's actually how it takes routes out of service, is it sets the route to 16. All right, and with the max hop count of 15. Yeah, so if you have more than 15 routers and they're all strung in one row, you're not going to get to the 16th one, because it will take it out of service, take the route out of service. All right. There is a default route that you can set up with RIP. I usually don't. I always use static IP addresses for my default gateways. There are 2 timers that you probably should know about RIP. One is a 180-second timer that sets a route. So if it doesn't see an update from a router that has a route for over 180 seconds, it'll set the cost to 16, saying that route is unavailable. And then 120 seconds after that, after the timeout, it will take the route into what's called garbage collection, and it'll just delete it. RIP v1 and v2 use broadcast UDP messages to and from port 520, and that's how it does the request messages and response messages. It also RIP v2 can use multicast, which is usually pretty common now. Most of the routers default to multicast. You'll see when we go to set it up, I'm not going to hardly tweak any of the settings, because the whole point of RIP is it's supposed to be a quick and dirty. And that's what makes it so handy, especially if you're in a test lab or test setup and you're just looking, you're tired of typing in static IP address or static routes. You're going to love RIP. Okay, yeah, and so the multicast IP address is 224.0.0.9, and it sends and receives updates on those. You'll see that later. And RIP v2 supports subnet masks and its update messages, and it also supports authentication. So we're not going to set up authentication today. And like I said earlier, only use RIP v2 if your box that you're trying to set up only supports RIP v1, I wouldn't even bother. Okay, so let's take a quick look at what we're going to try to accomplish here. This is the drawing from our static routing video. that we did previously. And as you can see, or if you remember, we added static routing from the Cisco to the Juniper, saying 192.168.11.x network lives this way out that port. And we also added routing in the Juniper saying that the 192.168.10.x network lives that way. And we just kind of manually added those in. We also added a default gateway that, there, if you remember, there's another router right here. We'll just call it the management network router. And so we added some default gateway routes that basically route this guy in both the Juniper and the Cisco. All right, and then we also added some routes, some static routes in this management network, so my laptop could access these networks down here. It kind of does this number here. So, okay, so if everyone's still following me, so what we're going to do is I'm going to go ahead and leave the static routes in the management router right here, because I don't really want to turn on RIP on it, or turn up RIP on it. So we're going to leave those static routes in there, but we are going to turn RIP up on these two interfaces here, so we can eliminate the static routes pointing to each other and basically publicize these two networks through RIP and any other networks we decide to add. So that's pretty much it. Let's get started. Okay, so I updated our drawing a little bit. I added a couple test ports on the Xena Compact that we were using in the static routing video to test our connectivity. And it's always a good idea. Before you test anything, you want to make sure that your test bed's in good shape. So I'm going to go ahead and ping from the Cisco here to the Xena Compact on .11, and we'll go ahead and ping it on .10, and we'll reverse it coming from the Juniper, pinging .16 on the 10.16, and also pinging 11.16. So let's do that real quick. Ping 192.168.10.16. Yep. 16. Okay, so that's with the static routing. Let's see. Ping 10.16. And okay. And I want to do that. It's not really necessary if you're doing it in your own network, but is because I had to bring up this the Xena test set and turn on ARP and make sure the ports were working, and so when we turned up RIP, if it didn't work, then we'd be kind of scratching our heads. But so we know the static routing still works. Let's go ahead and let's remove the static routing. Okay, so we'll just start from the Juniper side. Let's config. And it's delete, routing, options, static. And then I think we can just copy and paste this guy in there. Yep, and commit him. Very good. And let's go ahead and do the Cisco now, and that's config T no. And we'll just copy and paste him. Okay. Control C and write him. All right, so let's redo those ping commands. There we go. So ping 11.16. Okay, that works. Let's see. I think that's on the Juniper though. Yeah, so that's on the Juniper. We're interested in the 10.16. Oh, well, that's kind of interesting. Wow, so he's redirecting it out as default gateway. The default gateway said, "Yeah, I know where that guy lives. Let me just send you there." That's pretty good. Okay, well, we might have to get rid of the default gateway as well. That's okay. We can always add them back in later. Let's find these configs again. And we'll just figure. The reason why I paused there for a second is I want to make sure, and you always need to keep this in mind when you're messing with the routing, and especially if you're not just sitting right there on the box on the console port. You don't want to whack your way into the box, right? Because then you'll be stuck, and you'll have to do a truck roll to go fix it, and that has happened more than once, and it's very expensive and pisses a lot of people off. Okay, so let's do a delete on routing options static, and we'll copy this guy in and copy paste. All right, commit. All right, excellent. We still have our our connectivity. That's good. Let's do that with the Cisco. Let's see, config T, no. All right, control C and write him. Okay, so that's good. I didn't lose my management connection. And in case you're wondering why, it's because my laptop is sitting right here on the 1.x network, and both the Cisco and the Juniper have physical connections to that network. So the only time that we really have need for those default gateways is if we need to route out to the internet or outside these networks. All right. Okay, so we've got the default gateways removed and the other static routes. So yeah, let's try our ping again. Let's see here. Oh, see, there we go. Okay, so that's from the Juniper trying to ping the 10 network. See, he doesn't have his default gateway to use anymore, so he has no way to get to it. And we'll do that with the Cisco. Let's see, ping 11.16. And nope, he is going to sit there and time out. Okay, so excellent. So now let's go ahead and now we need to add our RIP. And what we're going to do is we're going to add it, like I said earlier, on both of these interfaces right here to begin with, and then we'll add that default gateway later. Okay, so we've deleted the static routing, and I think I'm going to retire this picture. So I went ahead and updated our document that we're using, our SMB network design doc that we've been working on since day one. And I went ahead and added the two Xenas in here, ports just hanging off these little circles right here so we can look at it. And this is the same connection going between them. It's just a straight line connection like in this drawing right here. And we've got all the same port IDs and port numbers, and everything should be the same. So the only thing different is we don't have little clouds, but it just looks neater. Okay, so yeah, let's go ahead and get our RIP added in these things. Well, we might as well start with the Cisco. So you guys are gonna laugh. This is how easy it is to start RIP on a router. Ready? So we're gonna do a config T. And we're going to enable RIP. And so it's a router RIP, right? And that basically enables a RIP routing process, or router process, if you will. And we have to associate it with a network. And this can sometimes be confusing, but we want to associate it with this network here, right? So we're just going to say network 192.168. Whoops, 172.16.0.0, right? Because it's in /24 network. Now, you don't add a subnet mask to this, and this is where it gets a little confusing. And how it works is Cisco will go look at on the interfaces that have this prefix right here, right? And they'll go find it, and they'll just associate the subnet mask that's on that interface, which is /24, with this network. Okay, hopefully that makes sense. So okay, we did that, and we're going to sell it. We want to use version 2. All right, and then we're going to say redistribute connected. And what those are directly connected networks. So, for instance, this 192.168.10 network right here is directly connected to this Dallas router right here. It's on, I forget what port it's on, but it is. And in fact, we go look at the drawing right here if you want to see it. But actually, it's got a lag, if you remember, we provisioned that. So, so we want to redistribute through RIP the directly connected networks. And one of the unfortunate things it's going to do is also going to redistribute our management network. And but we'll look at that later. And okay, so actually, that's it. And we'll do Control C and all right. And yeah. So now, if we go look and do a show IP protocols, and here we go. Outgoing update filter list. Oh, okay. Sending updates, redistributed connected, and RIP. So it's redistributing what's connected and what it learns through RIP. Okay, that's what you want. Sending version 2, receive version 2. Yeah, you want to just lock that in. If you have a box that only supports version 1, I wouldn't bother. use another routing protocol. Automatic network summarization. Okay, maximum path for routing for networks. Okay, there's our network, and so we really haven't added anybody else, so he doesn't see any neighbors. Okay, so yeah, let's go up to our Juniper here. And that was pretty easy, wasn't it? I don't know how many commands that was. What is that? It's 1, 2, 3, 4 commands to enable RIP. Okay, and on the Cisco, let's see on the Juniper here. So we want to do a edit. Then we're going to do edit policy options, policy statement. And I'm just going to copy and paste this out of my notes. And we're going to, this right here is just a name. And it was actually in one of the Juniper documents, and I kind of like the name. It's fairly long, but it's also very descriptive, so I kept it. And then term 1. Okay, and that term 1 is a sub policy, and the Juniper will click through the different, and actually this 1 is just a name, right, as well. You got to call it term Bob, but it makes sense because it's the first one. So term name 1. You can also have term name 2, and they have different, and it'll just click through the different sub policies to do matching. but we're only going to have one. So I digress. Okay, so we've created a policy statement. A routing policy called advertise routes through RIP, and now we have to tell it what routes. So, and this is where it's going to search. So you're going to see, we're going to do a set. We're going to say we want to search from protocol. Call RIP. All right. So these are, we wanted to find learned routes from RIP. Okay. And we also want to, get routes from protocol. Got to spell it first. Direct. And I know direct's not really a protocol, but oh well. And that's kind of like the Cisco command that we just did, which was redistribute connected. This is they call it direct in Juniper ease. Okay. And last one is now we have to tell it what to do when it finds these things. We're going to say once it finds them, then accept. And the command is set, then accept. But you'll see it'll make sense here in a second. Let's do a show. Okay. So now it makes sense. So the routing policy, advertise routes through RIP, is going to look from protocols RIP and direct. And then whatever it finds, then it's going to accept them and redistribute them. All right. So that's good. I'll go ahead and commit this. All right. And exit. And okay, so the next thing we ought to do is create a routing group for our policy, because that's the only way Juniper will export, or where you can set export statements is in the group. So it's edit, protocols, RIP, okay? And then we're going to give it a name, group. This is for a group name, and we're just going to call it the RIP backbone. Okay, because it's in our backbone network here, right? Or a planned backbone network. Okay, so we'll call it RIP backbone. And we're going to set the, so we want to export the advertised routes through RIP. Okay. And that's what we want to export. So, and what we did up here, where'd it go? Yeah, right here. So this policy statement, advertise routes through RIP. And in this group, we want to export those, export what it finds, those routes it finds, right? So it's export, and then you just give it the name of what we just did up here. Okay. That's the name of our routing policy. And then we just need to add an interface to tell it which interface that needs to participate in RIP. And what that is this interface right here, right? Unlike the Cisco, it'll just go grab any interface that's connected, right? Well, in Juniper, they've decided that it'd be better if you just tell it what interfaces participate. Okay, so it's set. So we just need to say what interface, and they call it neighbor, which to me is a little bit confusing. And the name of the interface. So it's gigi -0/0/0.0. And that is, the .0 is a sub interface. So if we look at our config here for the Juniper, so gigi 0.0 or 0/0/0, and this unit 0 is a sub interface, and they want to associate this neighbor with the sub interface. All right. And I believe the reason why you'd have to go look in the documentation is because you can have multiple sub interfaces with multiple IP addresses, and they could be on different networks, right? And so if you did it with just at the interface level, it would try to suck up all the different IP addresses that are in the different sub interfaces. So you don't want that. Okay. That's a lot of talking for just a few commands. All right. And we'll just commit this. And I believe we're done. So, yeah. Let's see. Let's do a show rip neighbor. Okay. And I know this to me is very confusing. The neighbor to me should be the Cisco, not the Juniper itself. But anyway, so yeah, you can see the state is up. 117.16.0.2. Yep, that's the interface we associated it with. This right here is that multicast address. It's using multicast, and it's in send and receive mode and in metric 1. All right. Oh, and by the way, that took let me see, let's count these commands. It took 1, 2, 3, 4, 5, 6, 7, 8 commands. So yeah, that's pretty short. And also, just to prove that everything is actually working, we'll just ping 192.168.10.16, which is, so we're on the Juniper. We're going to ping this network here. Yep, works like a champ. And from the Dell side, or from the Cisco side, we'll ping 192.168.11.16. Look at that. So if I wasn't just blabbing away, and I could have set this up, granted I have to kind of go through the documents because I don't have all these commands memorized. But, if you're doing this in a few different routers, once you got figured out what commands you needed, and as you can tell, there's not many of them, you could probably do a whole network of routers in a few minutes. Okay, so last thing I want to do is just go over a few commands to look at RIP and both routers, and then I think we'll just call it a day. So, okay, we'll start with the Cisco, and the first thing you want to look at, I guess, is the show routes, show IP route. And if it has an R, it is a RIP learned route. And that looks like it's the only one that it learned from RIP. Is this one right here, which is exactly right. It is the 11 network on the Juniper right here, which is perfect. Okay. And so we can look at some RIP stuff too. We can do a show IP protocol. Protocol calls. Yeah, so here's some stats on it. I think we kind of looked at this a little bit earlier. It's routing for this network. And here's his neighbor right here. Okay, and then let's see. Oh, the last command to look at would be the show IP RIP database. All right. And this kind of shows what he's learning and what he's summarizing, and this right here is a little bit confusing. I don't know why he thinks that's the major network, and if you'd have to dig through the Cisco document, I think he thinks this is a supernet, and there's probably a way to fix it, but I'm not going to, because the whole point of RIP is it's supposed to be a quick and dirty. If you want to get in there and start screwing, um, start turning knobs and tweaking config, then I would suggest OSPF or another. Well, I would suggest OSPF, and it's got all kinds of knobs you can turn and make your network run just like you want it to. But we'll look at this stuff, and so it says it's directly connected to /24. According to the Cisco doc, it should be advertising /24, but for some reason it's auto summarizing it into some supernet here. And yeah, you can see right here. So he redistributed his default gateway, which is probably not desirable, but we don't really care. I mean, we're going to add the static routes back in. In fact, we need to do that. Let's do that now. So let's see. In the Juniper, we'll do a config and do set routing. Routing options static. Let's copy and paste this guy. All right. And this is an alarm right here from my power supply. I don't have redundant power supplies. I have a redundant power supply, but it's not powered up. So that's what that is, if you're wondering. Okay, so we added that. So we added our static route back in our Juniper. Let's add it back in our Cisco here. This guy right here. Okay. So now if we do a show IP route, yeah, here we go. Okay, so now we've got that. So let's see, go up here to the Juniper. We'll just look at these quickly. So it's a show route protocol RIP. And look at these. So he's got, looks like 9 destinations, 10 routes, 9 active, 0 hold down, 0 hidden. And I guess this is if he's added or subtract anything lately. And so, yeah, so he got the .1. See, this is the IP address of the Cisco, right? So he got his default gateway guy, and he also got the .10, which is good. And this is kind of a weird thing. This is a Junos thing, but this is actually the multicast port. So what's another thing we can look at here? We can do a show route. And then if you do this advertise protocol and RIP, and then it's asking for the neighbor, which this just confuses me to death. The neighbor is actually the local guy. In fact, he says it right here. I guess it's confused so many people they had to actually put a note in there to tell you it's the local. And what it's looking for is an IP address. So it's 172.16.0.2, right? So he's looking for the IP address of this interface right here, which is .2. All right. And, okay, so this is what he's advertising. So this is what's being sent out that interface, if that makes sense. And it looks like, it looks like he is metric 2. That's interesting. Oh, that's right. We did tell it to redistribute the direct. Yeah, that's right. So he is advertising his default gateway as well. He's also saying, yeah, I also got that network from this guy here. But he should not be sending that back to the Cisco because you don't want a routing loop going on, right? So anyway, and then 192.160. Okay, so this is what he's sending to the Cisco, which is the one we really wanted in the first place. And I'm sure there's some knobs in there we could turn off the default gateway, but like I said, we don't care. Okay, so what's another command here? Let's see, we do a show route And then there's this receive protocol. So this is what it's receiving from protocol RIP. And if you look at this, now it wants the peer. So the peer is the IP address of the neighbor, which, tell me that's not confusing, but it actually is looking for the IP address of the Cisco right here. 172.16.0.1. Okay, and so these are the routes that it's receiving from the Cisco, which is very good. It's exactly what we want. And of course, it did it lickety split, as I showed earlier. We're able to ping immediately. And if you're wondering if my laptop still works, so I can ping 192.168.10.16. Yep. And I can also ping 11.16. See? Now tell me that wasn't fast. This is why routing protocols are nice. And if you really want to have fun, you can do a trace route from your PC and 192.16. Oh, boy, 168.10.16. A lot of sixes in there. All right. Okay. So, yeah, so for my PC, the route it took is 192.168.1.1, which is the default gateway, right? And then the default gateway said, yeah, I know that. I have a static route for that guy. He's at 1.75, which the 10 network is definitely hanging off 1.75, right? Here's a Cisco. Here's the 10 network right here. So that is correct. And the reason why I was checking this, I didn't want it, because since these routes are getting advertised or re-advertised through, I didn't want it to try to send it, back through the Juniper. And so, yeah, let's try the other one. We're just playing around now. Trace route 192.168.11.16. Okay, so this should be going through the Juniper side. Oh, and by the way, if you try doing these commands in the Juniper or the Cisco router, don't bother. I have never, ever got those commands to work properly in either box. And the only reason why it works better in Windows than it does in the Juniper, the Cisco routers, is because Windows decided they wanted to fix it. So they fixed the command, and instead of using UDP packets, it sends actually ICMP packets to the devices, and most devices will respond to ICMP ping requests. Anyway, it's just a little aside there. So, okay. And let's see here. We've got, so, yep, back to the default gateway right here, 1.1. And then this is interesting. So he said 11, he said 192.168.11.16, he sent it back to the Cisco. That's not good. Yeah, and okay, then of course he the Cisco said, well, he doesn't live here, he lives over there. So he sent it to the Juniper. This is the IP address of the Juniper. And he gets a strange timeout again, and then he gets to this network. And I don't know what this timeout is. Maybe it's trying to ping the lag IP, or who knows. And we'd have to do like a Wireshark or something to figure out what's going on. But like I said, we don't really care. And I'd have to get in my Cisco router. I mean, these are static routes. So I'm guessing I just fat fingered in a bad route for 11.2. I mean, sorry, 11, the 11 network, because he should be sending it. Oh, I know why. Oh, that's interesting. So, well, no, I don't know why. I'll have to. I was thinking that maybe we changed IP addresses of the Juniper to .78. Where is it? Management. Here it is. Oop. We changed it to .78 right here. And I thought maybe I didn't update my static route, but it shouldn't have sent it to .75. I don't think I have a backup for it. So I don't know. I might investigate that. So I pulled up my management network router, and geez, I have some bizarre entries in here. So, I mean, this I know and was expected, and this I expected, but I have no idea what these two. I don't know what I was thinking. I must have been smoking crack that day. Anyway, yeah, so the 10 network should be going through 1.75, and the 11 should be getting sent through 1.78, but I don't know what that is. I'm gonna go ahead and take those out. And okay, so I took those two routes, those two bizarre routes out. I'm not exactly sure what that was all about. And now we have the two regular routes. And as you can see, it should be sending 192.168.11.0 network traffic directly to 1.78, which is his management IP address. So let's try that again. I don't know, maybe those bizarre routes are messing it up. Okay, so as you can see, it definitely fixed that that routing problem. That is just bizarre. And I don't know why those entries were in there. I don't remember adding them. I was probably testing something and forgot to take them out, or maybe I just fat fingered them in. Who knows? So anyway. Wow, that was a kind of a sidetrack, wasn't it? Okay, so there's a couple more Juniper commands I'll look at real quick. One of them is show rip neighbor. I think we did that one earlier. Yeah, here's this multicast. I think we did this one earlier. And the other one is show rip statistics. So these are updates being sent, triggered updates, RIP v2 updates, which is good. We shouldn't be getting any RIP v1 stuff. We didn't enable authentication. I'm not going to. If you can read on how to do it, it's not that hard really to set up, but I wouldn't bother. This is just for your internal network. Like I said, this is a quick and dirty. If you just are tired of typing in static routes, right? If you want to really get in there and turn a bunch of knobs and use OSPF. So I think that's about it for this video. If you have any questions or comments, leave them in the comments below, and I'll see you next time.